Okay, so this is our new version of Robotic platform. It is based on a Mini PC, Linux edition of MK802. It's a quad-core ARM processor Mini PC. So this is it, actually. So this is used in our Robotic platform. The Mini PC is connected to all the devices here. So here we have the camera connected. We have here a connection, a USB connection to Arduino, and power supply on our Robotic platform. So this is installed like this. So here we have we use Arduino Mega 2560 to control DC motors with pulse width modulation, to read the sensors, and also control servo motors. So in our Robotic platform we have two DC motors for controlling wheels, two servers to control the camera direction and height. Should I say height? Okay. So we also have this gripper to grip things, for example, like a battery. So this is performed in this way. So what else we have here? This is goes like this. So probably I should show it from another side. So we have here a battery pack of 5 batteries, about 7 volts voltage, and we have a voltage regulator. This is needed for our Mini PC because it requires exactly 5 volts to operate well. Here we have current sensor and power switch. Okay, what else do we have here? Yes, each wheel has a sensor, so we can estimate the frequency of rotation for each wheel. So I think this is an infrared sensor. Also here we have an ultrasonic distance sensor, so it estimates the distance to, in the direction of where the camera watches. So also we have here a laser pointer to point at something. So, and well, okay, a little bit about the software. So here on this Mini PC we have a node.js server installed. So the key idea is that there is a little piece of code here in JavaScript that controls Arduino, and Arduino controls DC motors with PID controller, and also all servo motors to control the camera and the grabber. So on the client side we have a simple interface to control the robot go forward, backward, spin left, spin right, grab things, move the camera, and so on. So it can be controlled with different devices like cell phones, smartphones, from any stationary computer or laptop. So this is actually the key idea. So I think this is it. You can see how it works in different movies. So thank you. See you.
Okay, so we should now try our new mobile robot platform on the ground. So let's test it. So I will now press, of course, forward button and try to navigate to get the battery between between the boxes. Okay, so this is the control interface. Now let's see whether we will do it. Okay, so now we should grab it. Okay, and go back. And now we should go outside. Okay, so this is the control interface. The robot has PID algorithm implemented, and it works reasonably well. So let's go outside of our laboratory to see what is going on. We can also, for example, increase the camera angle, as you can see, or lower it, and we have planned the combination with the distance sensor. So the commands are forward, then we have left forward, right forward, then we can spin left, spin right, then we can go left backward, and of course backward, straight backward. We can observe the PID algorithm working. Then we can go right backward, and stop, of course, and we can release our battery and go backward. Let us test the PID algorithm that is implemented on the platform. Let's first prepare the box with some weight. So let's put these few profiles and the wooden box inside, and let's test the working of the platform if we put some weight for the robot platform to push. So as we can see, when the platform comes to the load, it continues to remain the speed. This is possible since we have two encoders, one on each wheel, and of course with implemented PID controller. But let's not push it too hard. As we can see, the platform maintains the speed, although of course it's a little bit heavy for this platform.